I was asking him, I said, what are all these charts right here on the wall? You know, I said, explain to me what they are. You know, and I says, and do you see value in this whole concept? You know, he looked at me. He says, the question I have is, do you see value in it? And I had a difficult time. Didn't have a difficult time. It really, shocked me, because I thought I was showing value by asking him about those charts on the wall. And he went on to proceed to tell me the value he saw in TPM and how TPM has improved the performance in the yarn finishing organization, and why he is a strong proponent of that concept. I would have thought that I was in a seminar.
To us, TPM prevents a lot of downtime, especially the unplanned downtime, so to speak. If you can keep up with TPM, then you can prevent all that, and that helps with the scheduling, keeping the plant on schedule.
We say in our plant that under TPM, total proactive maintenance, total productive maintenance, that it's maintenance's responsibility to produce plant capacity. Not to fix things, not to do a lot of these other things, but to produce plant capacity.
Hello, I'm Bill Quiet, and this is Teletrain's instructional series on total productive maintenance. Everything about TPM is based on and aimed at improving equipment effectiveness. Now, almost every business uses some method, or perhaps several methods, to evaluate its efficiency, and most large businesses generate very detailed reports. But how beneficial are these reports to the equipment operators and maintenance employees who actually control the equipment? In this program, we will introduce a quick, simple way to evaluate equipment effectiveness. It is not intended to replace the evaluation systems you currently have in place, but it is intended to put useful information into the hands of the people who need it, when they need it, and where they need it. Best of all, the information will highlight areas of lost efficiency, as well as the cause of the loss, so that overall equipment effectiveness can be improved. And that, once again, is the fundamental premise of TPM. In this program, we'll show you how to calculate overall equipment effectiveness. We'll identify the factors that can negatively influence your effectiveness rating. And we'll show you some real-world examples drawn from businesses you're almost certain to recognize. But most of all, we hope to illustrate the importance of equipment effectiveness, not just because it's the foundation of TPM, but because it's so absolutely vital to business. Now, overall equipment effectiveness, which is often abbreviated OEE, is determined by evaluating your equipment and then rating it in three categories. The first category is availability. The second is performance. And the third is quality. We'll look at each of these more closely. Availability is simply the percentage of time your equipment is actually in operation as compared to the amount of time it should be in operation. Let's say your facility operates 24 hours a day, 7 days a week. If the equipment you are evaluating is scheduled to run continuously, it should deliver 168 hours of service over the course of a week. Of course, not all equipment is scheduled to operate continuously. The machinery shown here, for example, is expected to be idle during meals, breaks, and routine meetings. In this case, the first step is to make sure you have an accurate number of service hours a given piece of equipment should deliver, which means that planned downtime is not included. To keep our example simple, we'll focus on equipment which is operated continuously, and we'll say there are no planned outages this week. So our net availability is 168 hours. But let's say that during the course of the week, the equipment suffered several small breakdowns and was out of service for a total of 10 hours. 168 hours minus 10 hours of downtime equals an actual operating time of 158 hours. To determine our availability rating, simply divide the 158 hours that our machine actually delivered by the 168 scheduled hours it should have delivered, and we find that our machine was available almost 94% of the time. That may sound good now, but you may be surprised shortly. The second category of overall equipment effectiveness is performance. Let's say that at full speed, our machine is designed to produce 100 pounds of product per hour. But if its actual production were only 90 pounds, we would be getting 90% performance. Again, this may sound okay, but wait. The last category of overall equipment effectiveness is quality. Let's say that out of the 90 pounds our machine produced, 5 pounds did not meet specifications and could not be shipped. So 85 acceptable pounds divided by the 90 pounds of total production represents a quality rating of 94%. Now that we have a rating in all three categories, we simply multiply them together to get our overall equipment effectiveness rating. 94%, or 0.94, times 90% times another 94% equals 0.795, or an overall equipment effectiveness rating of just less than 80%. Let's think about that for a moment. Our overall rating is 80%, even though our ratings in all the individual categories were above 90%. But really, this makes sense. Our goal is 100% effectiveness, but our machine is available only a percentage of the time. And when it is available, it is running at only a percentage of full speed. And even then, a percentage of the finished product is unusable. Each factor chips away at our goal of 100%. What we have left is our overall equipment effectiveness. OEE isn't just a number. It's an accurate reflection of the service we actually get from a piece of equipment, as opposed to the service we should get. But what creates the difference between actual and should? What causes lost equipment effectiveness? Well, let's return to the three categories of OEE: availability, performance, and quality. For each of these categories, we'll identify two major causes of loss. In the first category, availability, breakdowns are an obvious cause of loss, but the time required to set up and adjust the equipment between production runs, for example, is also lost time. In the performance category, losses caused by reduced speed and those caused by minor stoppages are enormous drains on some companies. Their equipment runs, but it doesn't run smoothly at full speed. So it's a trade-off between backing down on the machine or fighting one jam after another. Idling refers to occasions when the equipment is running but isn't actually producing or providing service. This is commonly caused by delays upstream from the equipment. In the quality category, defects in the process are a likely cause of poor quality, but a loss is also encountered from the time a machine is started until it reaches stable production at full speed. These are referred to as startup losses or reduced yield in some cases. Taken as a group, these are the 6 major causes of loss. In reality, there are, of course, more than 6 causes of loss. Some sources refer to 12 or perhaps even 15 causes of loss. Ultimately, however, your organization knows its own operational problems better than anyone else, and you can identify as many or as few causes of loss as you wish. We will focus on these 6 primarily because they are almost universally accepted among TPM organizations and because they provide a manageable starting point. Again, you can modify them as you see fit. Let's consider each cause of loss in greater detail. Breakdown is, for the most part, self-explanatory, but it should be made clear that the loss created by equipment failure is more than the cost of the parts and labor necessary to repair the failure. It is the lost production which is most expensive. In his book, Total Productive Maintenance, Terry Wireman makes a reference to a survey of manufacturing firms which suggests that, on the average, the value of the lost production is 4 times greater than the cost of the repair. So if the repair of a breakdown cost $1,000, an additional $4,000 of production is lost, bringing the total cost of the failure to $5,000. Now let's look at setup and adjustment losses. Even in the largest continuously operated plants, some equipment is used only occasionally, so it must be set up and adjusted before it is available for service. There is also time lost during product changes on a manufacturing line or during batch changes in a process industry. The device you see here machines aluminum to be used as part of the skin of an airplane. It isn't uncommon to spend 12 to 18 hours setting up for an operation that takes less than 10 minutes to perform. Before we proceed, a point should be made that availability losses involve the complete loss of equipment function. Performance and quality losses involve only function reduction. Experience has shown, however, that in most organizations, function reductions detract more from overall equipment effectiveness than do complete function losses. They should not be taken lightly. So let's look more closely at performance losses. Once again, they stem from reduced speed or minor stoppages and idling. Industrial machinery is extremely expensive. It is not surprising that the company owning the equipment wants it to run at the speed, capacity, and production level its manufacturers said it could. But as the machine ages, it may begin to lose a portion of its original speed, and the loss will become greater as the equipment continues to age. If this loss of performance is accepted as a fact of life by operators and maintenance personnel, the full capacity of the equipment is never restored. On the other hand, equipment operation may simply become unstable at full speed. Over time, jams will begin to occur more and more frequently. This leads to minor stoppages so the jams can be cleared. Many wise old operators have learned that rather than running equipment hard and encountering one jam after another, they can cut back on machine speed and actually get more production because the process stabilizes. Nonetheless, production remains below target because the machine is not running at target speed. The alternative is to run the equipment as fast as you dare and fix problems as they occur. The problem with this approach is that every little jam eats away at production, and the faster you run the equipment, the more jams you encounter. Every machine operator has a personal understanding of the problems associated with start, stop, hurry up, and wait. Returning to the third and final category of overall equipment effectiveness, quality losses include process defects and startup losses. One of the lessons of a mature quality program is that reliable, high-quality products and service do not come from unreliable, low-quality equipment. This is where total productive maintenance intersects with and complements total quality management. In your organization, you may or may not wish to think of TPM as part of a total quality effort. Either way, your equipment is primarily a factor in the quality of the goods or services your business provides, and eliminating defects in your equipment is a big step toward eliminating defects in the end product. As for startup losses, some equipment must reach full speed or operating temperature before it begins to stabilize and its output begins to meet quality parameters. The longer this takes to happen, the more waste or rework you will have. Now that we've reviewed 6 causes of loss, you can probably see the waste they create. In fact, you've probably experienced several of them. The truth is, every piece of equipment is susceptible to one or more of these losses. All too often, however, the true cost attached to these losses is either unnoticed or unknown. For example, minor stoppages are an irritant for operators, but does management really know the cost they create? Do you? If you could eliminate minor stoppages, how much hidden capacity could you find in your equipment, and what would it be worth? Let's use an imaginary example. Suppose the conveyor which delivers coal to these rail cars shuts down occasionally because a loose piece of coal falls into the drive mechanism and causes jams. The equipment operators tolerate it because it seems unavoidable. Besides, it only happens about twice per shift, and it only takes 10 minutes to clear the jam. So 20 minutes per shift is lost. Big deal, right? Now multiply that 20 minutes by 3 shifts per day, and 1 hour is lost. If the conveyor is designed to deliver 100 pounds of coal per minute, 6,000 pounds or 3 tons of coal didn't get shipped today. If the coal sells for $30 a ton, $90 worth of business was lost. Over the course of a week, $630 of business is lost. Over the course of a year, almost $33,000 of business is lost. Would it be worth it to fix the conveyor? This is what hidden capacity and overall equipment effectiveness is all about. We'll close this program by offering 2 cautions about calculating your equipment's OEE. First, OEE is simple enough to calculate if you have the data. Some equipment includes monitoring devices which can generate the raw numbers for you. If your equipment does not, data must be collected manually and some decisions will have to be made. How can you keep track of very brief stoppages? At what speed should the equipment be running? The second precaution, there's a common temptation to want to calculate OEE for an entire facility, department, or manufacturing cell. Try to avoid it. First of all, it just doesn't work because a problem in one area today can slow up everything downstream tomorrow. In other words, your data will be suspect. Second, OEE isn't calculated just for the sake of having a number. It's supposed to show you where loss is occurring and identify the type of loss. That way it can be stopped. Suppose you did manage to come up with an OEE rating for an entire plant and it was terribly low. Where do the problems lie? What kind of problems are we talking about? You really wouldn't know. You're much better off calculating OEE for individual pieces of equipment. And don't forget the conveyors in between machines. Conveyors can sometimes suffer breakdowns, speed losses, and quality losses, just like any other piece of equipment. I'd like to thank you for joining us in our look at overall equipment effectiveness and the causes of loss. We hope it will spark some new ideas and maybe even help you discover some hidden capacity in your equipment. For Teletrain, I'm Bill Quiet.